Okay, we're going to get started. This talk is the Internet of Thingies. Our speaker is Ken Eshelby. He's with Opennms, and the talk is about how to do the Internet of Things for do-it-yourselfers and people that want to use open hardware designs and open source software. So without further ado, I give you Ken.
Thank you. Before I start, by raise of hands, how many of you have tinkered with making hardware, little things, soldering, electronics, hobby kinds of things? So about half of you. Okay. So if this is too pedantic, hurry me along or something. For the rest of you, this might be a good introduction. It's meant to be basic enough for you to understand. Toward the end, it's going to get a little advanced because the software of the company that I work for, Opennms, is kind of an advanced monitoring software. So I'm not going to go into a lot of detail with that. So we'll get started. They always say start with a joke. And the joke is my clicker doesn't work. Sorry about the microphone. It's kind of hokey. So the joke about the IoT is that all these things are going to take us all over, and we'll be their servants eventually. Maybe, hopefully, maybe not hopefully, I don't know. So my interest in this is basically around my home, trying to do things more efficiently and learn about the environmentals around me and how I'm using energy and heat and any ways that I can do to control my energy use. So to me, that means collecting data and analyzing the data and making decisions based on this data and using comparative data. So typically for home systems, what you see are diagrams that look something like this, maybe. There are a lot of varieties of models out there, but this is kind of what I'm talking about, sprinkling smart hardware with software on it that does various things like control systems and measuring systems and access systems. And there are tons of products out there for you to check out. This is another kind of model, a little more cleaner, but this is typical of what you see. I really like this one, but I have no idea what it says. Does anybody speak Russian or read Russian? Someday I'll Google Translate it into a normal. And then this is where things can go. This is the fear in the machine overlord kind of thing, where you're being blackmailed by your devices to turn up the heat or not watch what you do. So anyways, that's the end of my joke segment. If you stay at the Westin, there's a nice walk you can do. If you go just down the mall where the restaurants and shops are across the street and keep going to the city hall, the big rotunda, walk under it and out to the courtyard. And in the corner, each corner of the courtyard are these things, and they have a little motion sensor, and they make animal noises and other weird things. And I don't know why they would do that other than maybe keep people from sleeping there, because I've run into people in sleeping bags out there at night, so I have no idea. Go check it out. If you do keep going to the Westin, you just go straight on through, across the street, and you're into like this little man-made creek and mosaic tile thing, and that just takes you right to the Westin. It's a really nice walk, keeps you away from the traffic. Okay, so these are the design goals that I was working with. They're a little vague purposefully because not all things fit, and you have to pick the priorities of the components you want. I might use the handheld phone. All right, sorry about that. And that didn't help. So this is my beginning point. You need kind of a set of tools. You don't need this much, but you need some of these things because you're working with measuring voltage, inducing voltage to work with the pieces. There's some circuit boards and things here. There's a little jeweler's screwdriver kit, electrician's scissors, soldering station, a variable power supply, and then like freaking forever components and pieces and stuff, and junk that you get from things around the house sometimes. My advice for things that you get is it's hard because unless you have hands-on, you don't know if something works for you or not, but get things that are helpful and make things efficient so you're not fighting your equipment. So try to buy quality things like the soldering irons, like a, I don't know, $50, $60 one. It's not a $15 one from Harbor Freight or something. Probably shouldn't say Harbor Freight, they're a customer. But the kind of discount tool places. So there's a variable power supply. That's really important because different components use different voltages and they can tolerate different amounts of amperage. So you have to be careful about these things, or you let the magic smoke out of the electronics, and that's not a good thing. I've done that, maybe. There's kind of a simple list. Again, better quality makes working with this stuff more fun and easier. You're not fighting screwdrivers that strip or things like that. Power supply is not required, but it's very useful. And be sure to light up your workspace and give yourself enough room to work. It's like simple things that make a huge difference and makes it more enjoyable to do this kind of thing, because you end up spending a lot of time at this, so comfortable. What a picture of a breadboard with a Arduino, and these are the various sensors. This is kind of a higher accuracy sensor. These are all temperature sensors. This is a waterproof one. This is one with humidity on it, and then this is kind of a really cheap one. And so when you're looking at components of the pieces of what you want to build, whether you're measuring voltage or amperage or temperature or humidity or pressure or whatever, light, you have to find what's out there and what fits you. So you can see that these different components have different characteristics, and some may work better or worse for your application. So what I found in my case was that this BMP 180 seemed to be the most robust for me. And it uses I2C protocol, which makes it really easy to hook to the thing that's going to take the data in and then work with it. This one is another one that I use because it's got humidity built in too, and that's useful to know around the house. Just for, I don't know, I have a basement, and it's interesting to watch humidity in the basement and in the garage and outside and inside and see how they change, and if you can affect it by insulating and different things like that. So Arduino is one way to go with this. It's okay, raise a hand who knows what Arduino is or is familiar, I guess, with it. So most of you. So that's the basics of Arduino. They're very cheap now. They have a lot of utility. They're easy to work with. They have their own environment to develop. They're easy to connect to, and there are a lot of tutorials and examples out there. So honestly, this is a good starting point. Let's see. I'm gonna have to look at my notes too, once in a while. This is the IDE. It gives you a serial console, so you can watch debugging of what's actually going on. And it has a variety of libraries to work with the different hardware, to work with, to have a web server built in, and it's really easy to work with. It's probably the best if you're starting out. So for this project, I wanted to communicate over IP. So that's a component of my requirements, and these are the possible characteristics and possibilities that I can work with Arduino. SNMP, which is a common networking protocol, is very flaky on Arduino. It's not consistent and reliable, so I kind of had to throw it out and use something else. Our software can collect from a lot of different protocols and methodologies, so I went with something else. But this is I'm kind of showing you the approach. So these are the things that you look at, you match it with your hardware and your software available and the whole system, and you decide whether or not it works well or not for you. So next, I looked at this little thing. It's an ESP8266. It's really cheap. It's really tiny. It's very simple. It has it can take digital and analog inputs. This one happens to be 3.3 volt. You can see it's a model. It's a generation, I guess, ESP01. It's the first iteration of this board. The cool thing about it is it's got built-in Wi-Fi, so you can connect it to your AP and it becomes a client, right? It has a built-in TCP IP library. It has a built-in web server, so it's miraculous. It's a magical little box. And what did I say the price was? I give a price? About $5 for that one. So here's a prototype using ESP8266. So I just wanted to show this note because all these details matter. So the thing itself operates at 3.3 volts. You got to make sure you deliver 3.3 volts to it, or you cook it and release the smoke, and then it doesn't work anymore. So to do that, you usually have to take some other voltage and drop it down to 3.3 volts. So that's what this thing is a voltage regulator. So typically, you get like a wall wart that outputs 5 volts or 6 volts or 9 volts or 12 volts, and you drop it down to 3.3, and the regulator's like $1. But if you don't get the heat sink for it and you're feeding it 12 volts, you'll burn up the regulator. So on and on and on this goes, right? Every step of the way, you have to be careful about everything you do, and you learn. And luckily, it's cheap to learn. So. And so after you do all the things correctly, put your code in, this is the kind of result. So I just built a simple web server that gives me a page, and now I can collect it with the network management software. So this is a very, very basic model for this approach. So then, well, that's not good enough. I want something better in different ways. So you go about it again, make a new iteration of it. One thing about this is that you can't just plug batteries in and let it sit somewhere and run. That's kind of my dream, is to have it truly wireless and remote, so I don't have to rely on house power to make it operate. That lets me put it in places that you otherwise couldn't put it. Thank you. And it lets you be more flexible in where you collect and how long you collect. So the previous design didn't fit that, so I had to you try over and over and get better at this. The other problem is that that 01 model has a really weird pin setup. Maybe here, you can see there's 8 pins, and they have to bridge this gap in the prototype breadboard. So, well, actually, there's the better one. So I bought an adapter that those pins plug into, and they come out and they spread and can bridge the board gap, but they don't fit. So the pins down here don't fit the square. They're different types of pins, so it's loose. It just comes out, which, right, that sucks. So I take a battery clamp and clamp it to it, and that's that works for a few days until you get annoyed with it. So then you can, somebody did this, you can heat up a pin and then pull it up and then solder a kind of a L-shaped right angle set of pins to it, and now you can bridge this gap. It's a really hokey fix, but it works well, and it seems to be reliable. But that's kind of silly, right? You have to do this for everyone, and it's just not a clean, efficient approach to it. So the other thing about the first way that I was doing it is you have many components. So I showed you the voltage regulator. Well, I got one off eBay that's kind of an all-in-one. It's got a built-in kind of heat sink and way to deliver clean power. It's not as like physical mechanical. It's got some smarts to it, so it's a better tool to use. However, it's not reliable. I've killed 2 of these things. Likewise, you have to have a switch to do the programming of the ESP8266. I'm showing this with an Arduino, but that's not really involved in this. I'm just sorry. How did you kill it? Was it fault or bad manufacturing? eBay, Chinese special kind of a thing. And honestly, that's really a good way to go for if you don't know what you're getting into, because you can buy a 5-pack for $10 or $5 or something, and you've got 5 to kill in new and creative ways each time. So, right? It's honestly buying many of things at the start, or a couple at least, right? Figure you're going to destroy one, and you might get one to work, and then determine if it's flaky or not, or maybe it's your approach or something. But you run into a lot of bad hardware in this, so that's just kind of how things work. That's life. So I found, I've been aware of this one, but I found, I guess, the 12th generation, but they're not all, don't do an incremental thing. But anyways, Adafruit, which is a popular Arduino retailer, they sell a board that's based on the ESP12 model of this chip. And it has the voltage regulator and the programming reset buttons, and a whole load of inputs and outputs on the side available. It's got pins for connecting USB. It's like pretty much all in one. So that plus the BMP 180 temperature and pressure sensor, it's a lot more simpler than multiple components, the physical components. And I found that these are incredibly reliable. I haven't had one die since the summer, and we had a hot summer in Oregon, so it's been a good box. It's survived freezing, and December was the 2nd wettest month for Oregon and Portland ever, so it's had a harsh environment so far, and I haven't had to go out and reset it or do anything, so it's been really good. You have a lot of options with it. It's $10. Like I say, I haven't killed one yet. I have 6 of them running, I think. So it's been a really good board for me. So software side, how do these things work? You can run the Arduino IDE with these ESP8266s, but you can also flash it to something else, anything you want. You could build your own firmware and your own development and your own code and language to use with it. By default, it comes with Lua programming language, so it's got a firmware that includes the IP smarts and the web interface, and Lua is the language you use to program it. But I'm just showing you Node MCU is kind of the ringleader for these. It's a popular one, and this is just a flashing utility, and this is the way you load different firmware and make use of different ways of programming these things. So the Lua language, here's your Wikipedia for it. It's a popular language. It's widely used with different applications. There are some of the applications, and not even close to it. Maybe that's 10% or 25% of what's on Wikipedia. But you can see it's pretty widespread use. I do this because there's games, and that's probably 5 or 10% of the list that I saw. But popular games use it to make mods or to be their front end, or it's an interesting language. It's used in the systems management and networking world for various things. You can see previous slides. Cisco ASA devices use it. So Conky, if you've ever used that on a Linux desktop, it's widely used. So it's kind of a nice language to use because a lot of people use it, and there's a lot of knowledge out there for it. So this is, for example, this is a temperature sensor. That's the temperature and humidity one. It's a library for it, and that's the file, and you get it, and you use this little IDE environment called ESXplorer for ESP8266. you load the DHT, that Lua file, and here's kind of the loading, or the console screen for it, and you upload it, and I don't show it there, maybe on the next one. Well, anyways, oh, this is removing. But anyways, you load it, and it will show on one of these slides that the file is here and loaded, and there's your library, and then you load basically your program, and you execute it. And then when you reset the device, it's just running constantly, so it's kind of a loop thing. And based on whatever you've told it to do, it will constantly do that. It can do things like you can set it to a deep sleep mode and wake it up every so many minutes and have it send something, or you can leave it on like I had for this one as a web server, and it's just waiting for somebody to query it and get values from it. You can do whatever you want, so the sky's the limit. So this is the uploading of that file, and then I learned how to do highlighting in whatever screen capture I was using, and you can see the file there. So right now we're getting advanced in my presentation. But it shows the file, the size of it, how much space you've got left, and here's the code of that library. And now, so because these devices have limited flash memory on it, there's a nice thing you can do that lets you compile that Lua file you uploaded into kind of a binary that strips out a lot of comments and things like that. So you can shrink it by, a quarter or a third of what the original size was. So it's kind of nice for saving space on it. And then you load what they call the Init file. The Init file is basically your program. So to go through this, all I've done is set a static IP. All the examples you'll find on the internet are for DHCP, and that didn't fit my model with multiple devices and having to monitor, because I had to go and, I have to identify a device and say, this is the outside sensor, right? And if it's changing IPs or contesting with the other things, you can't tell which one you're collecting. So I needed to set the IP address. So I've set that up. This is my SSID, and my password for my AP. I've basically defined some pins and some variables, and then I kind of do a run-through of the device itself, which is basically initializing it, getting some values, doing some calculations of those values, and then clearing out memory, doing garbage collection. I then take temperature and humidity and set up the web page basically, and somewhere pass it temperature and humidity values, and then it basically loops. So it's doing this every, I can't see that number, can't see it on mine either, but it does it every 30 seconds or something like that. So again, this is a very simple model. You can kind of see how you have some variability, and depending on what your use case is for this, you can set it however you like. Okay, so that's the hardware part. Do you guys have any questions about kind of hardware related and getting? Go ahead.
How do you manage the battery life?
So I gave it. I think the one I ended up with needed 4.5 or 5 volts. There was some number up in there where I ended up using 4 AA rechargeables. Those didn't quite last 24 hours set up as a web server. So what you really want to do for this is do the deep sleep and do a push collection. I wanted to keep the kind of presentation simple, so I wanted to present this. But that's going to be the next iteration, is developing a push model that's collectible and then presenting that as like the low power usage. Because I've run into people at maker fairs and things like that, and one guy's getting, I think, 1.5 years on a pair of AA's, kind of a thing. So that's the kind of place you can go with this kind of stuff. Makes a lot more sense at that kind of level than changing batteries out or having a big battery for it. So, yeah. Any other questions? Okay, so this part is the data collection side, and because I work for this company and use it and am a consultant for companies using this, I'm going to breeze through it. suffice it to know that there's a product in the world called Opennms. There's a couple of different versions of it. This is kind of a long-term support version. This is like a rapid development version. It's kind of the Red Hat model that we use. This would be for a production environment, and this would be for a test lab environment. Some people use this in production. Our software is completely free and open source, and it's an enterprise scale network and systems monitoring management platform. That's about as fast as you'll ever hear that description. So the configuration of it, I'm putting this here to just kind of document it. You don't really need to know these details, but we basically configure Opennms behind the scenes in XML. There's various front ends and ways that you can get data in, but somehow you have to get your sensors into the tool so that it knows about them and can collect values from it. So that's what provisioning is it's a way to do that. And it can be a very complicated process. So imagine if you have say you're going to build these little devices and deploy them throughout the world in all of your data centers and all of your, like, we have Papa John's Pizza as a customer, so they have 2,000 or 2,200 stores. They need temperature sensors for all those, right? That starts to be a lot of numbers. So you have to have kind of a sensible way of getting lots of devices into our tool. So provisioning is the way you do that. So we've got the nodes into the system. Now we have to configure data collection. And so what I've done is created a service, which could be HTTP or ICMP or SMTP, any kind of protocol. And I've just made one called DHT22 sensor because that's the type of sensor, and it's got its own set of parameters. So I've created in the daemon config a service that's called the sensor, and then I've defined a data collection based on HTTP for it. So ignore this, it's just the performance data store stuff, but I basically made a regex that looks for temperature, humidity, takes out the numbers for them, and then aliases the first one, which is in these parentheses, and the second one, which is in these parentheses, and match it to sensor temp and sensor humidity values. Now I've got values associated with these variables, and I can go reference them on, like, displaying graphs and things like that. So that's what I did. So I made a graph definition, and there's the graphs for one sensor for its temperature and humidity over approximately a week. So I think that's kind of cool, honestly, because you get a real sense of what temperature and humidity in this case does outside. I think this is an outside graph. Likewise, Opennms has other ways of displaying your data, including a plugin for Grafana. So now you can get kind of the modern sort of graph display of it. And in this one, I took multiple sensors, showed them all on the same graph. This is I think the kitchen sensor, the outside temp sensor, and the basement sensor, and they all had at the time temperature and humidity. And you can see what your outside humidity does in relation to your inside humidity. To me, that's interesting. Likewise, you can build little displays that you can set thresholds and change the color of the number based upon the values. So if it gets cold, turn the number blue, and in a glance you can see it's cold outside or something. I mean, that's kind of a silly example, but what this gives you is a way to display your data in a sort of immediate and impacting way so that you can see interesting things. You can see that for this, as the temperature drops, I think this is over a 24-hour period, as the temperature dropped, the humidity came up. And in Oregon, this was kind of late summer, so that's kind of a normal thing. It cools off in the night, gets a little more humid as a result, and then when the sun comes up, the humidity falls off and it gets drier outside. So you can see all that displayed visually. There's another display using Grafana, which is just the BMP 180 also lets you record pressure. So here's a graph of pressure, and then here's each individual sensor. With this one happens to have pressure, but I don't know why this one doesn't have anything, but it might have humidity or pressure. And then this one shows temperature and pressure together on the graph for these two sensors. So you just have flexibility in what you want to do. So expand that out to showing when lights are on and off, amperage are going across circuits, light levels in your house, other like doors opening and closing. This is the kind of thing that I'm kind of working toward in I don't know, this demo, this presentation. So I'll get there at some point. So again, I talked about some of this, but these are some of the lessons I've learned. The world is a mean and spiteful place, and you will pay. And honestly, what's not bad about this is you'll pay in a kind of a cheap way. It's not hugely costful to pay for tinkering with this. And this never used to be the case. Like those little ESP boards, something like that used to cost $60 like a year ago, and now they're $5 and $10. So this is the direction this hobbyist kind of electronics are going, and it makes this fun and accessible for a lot of people. So I kind of encourage you guys to go out and check it out if you've got interest in it. Again, buy extra things because one order is a lot less stressful than 2 orders or 4 orders or something. So get, maybe double whatever you think you'll need, or do something reasonable to cover losses due to various reasons. And then finally, some of my to-dos. This push collection is a big one. And actually, this presentation, I gave this in Germany, and it got one of our developers to think about push collections and say, hey, we need a streaming engine to receive push data to our software. So I think it's a good model for saving a lot of energy and making these a lot more attractive ways to roll your own kind of Internet of Things devices. So you need all these pieces in place that I just took you through to make all this happen. So now look at each piece and make it better and better. So that's kind of how we do it. So that's it. There's my contact info. Are there any questions or comments on this? Go ahead.
Have you looked at Google's effort in IoT? It has to do a lot with thermostats and sensors.
Yeah, so the question was, have I looked at Google's effort? And I've only looked at Opennms in terms of a central hub kind of. I'm assuming it's like a hub-based kind of model, and you connect various things like a Nest thermostat or other things to it. Is that? Okay. Yep, so it's kind of a matter of what you want to do. Are you controlling things? Are you just getting information? Are you like that kind of a thing? So I haven't dived too deep into that yet. I'm going to start with Opennms because it's an open source project that's built very similarly architecturally to Opennms, so I'm comfortable with the Java architecture and the way that he's structured things. So that's probably where I'll start, but I'm going to look at as much as I can because I will tinker endlessly with this.
Yeah, Google bought that company that does the thermostats.
The Nest thermostat?
Yeah.
Okay.
Their IoT effort is Nest.
Okay.
AT&T also has a IoT effort, an open source API.
Yep. No, I haven't gotten to that point yet. I slowly do this throughout the year when I get time to, but yeah, it'll get there. I've got an S, and I've got a developer key for it, so I've got it hooked to Opennms right now, but I haven't done much with it. So now that I have some accessibility to the thermostat, I can now use that key with other frameworks and work with those. So yeah, this stuff takes a while, Build an Opennms on a Raspberry Pi, get all that set up, and then start talking to it and figuring things out. All of a sudden, 3 weeks have gone by, kind of a thing. And, yeah, so, as time allows, yeah, totally I'm going to check out as much as I can. Any other questions?
Any recommendations as far as a community point for like-minded people?
There are tons, as I've found out. There's an ESP8266 forum that is heavily used. These are very popular little Wi-Fi things. So for that thing as the entry to a sensor data, or things like I've been installing a lot of LED strip lighting in my house. In the basement, I went from 4-foot fluorescent tube fixtures to all strips. and I think my power dropped from, or the drop in power usage of those went from like 300, almost 400 watts to like 140 watts. So I flipped the switch, and that's the difference in power. Now add to that things like a motion sensor. It detects you walking into the basement and then turning it off, and then having a 15-minute timeout if a sensor doesn't detect movement. Right, the savings in energy there. Things like on the front porch, I have LED strips that are, well, they're red, green, blue, so I can make red and green ones for Christmas and yellow and purple for Easter. That, but also dusk to dawn, a light sensor to detect dusk and dawn, turn them off and on based upon the light, and then when somebody walks up, a motion sensor that makes it brighter when they sense you're there. So all these iterations, help with that. So this is a very long-term iterative process, and each component that you work with, you can refine and optimize. So yeah, it's a lot of fun. I don't think I answered your question though.
You said there's a lot of stuff in there.
Yeah. So the resources online, yeah, it's easy to find. There's a lot of Arduino forums, yeah. What's the best one? All this kind of. You kind of find by which ones you like by the quality of the questions and the quality of the answers and how much activity. It's just like GitHub or SourceForge was, where should I use this open source software? Well, it hasn't been developed for a year and a half, so I don't know, kind of a thing. Any others?
You mentioned that you guys were going to do that
It's on the, so we're a open source community and project, so somebody wants to write that kind of a thing, they could work with our developers to do that. Our models are kind of community contributed, funded development, or an in-house. Because we usually work with large companies that may have an in-house development staff. So the need has to drive the people's time is valuable. So our developers really only write things that are funded. We don't write a lot of code for free. We tend to write features that our customers want and have paid for. So
the policy right now you're working on data file?
yeah, yep. Like the model I was going to do is stuff the values separately in like an XML file. Have our XML collected as the first iteration. Not have a new daemon or anything, but just come up with a way to separate out which value belongs to which device and at what time, and then plop it into a metric database, based upon the time, so that you can get normal-looking graphs out of it, kind of a thing. So yeah, I haven't gotten to putting that all in place, but I've started on that. But the bigger thing is a true streaming daemon that's one of, that fits in line with all the rest of our types of daemons and makes the real thing, and that we can speak MQTT protocol and all the other kind of IoT kinds of things. So yeah, that's where we're headed. Yeah.
This for historical values, you're shoving that into a database.
This right now, this one that I'm showing you was just I just have a Nook server, and it's just in RD files. We have measurements API that lets you just select any kind of data store. We have two. You can use RD with our natively out of the box. You can use RD natively, or you can use what a segue. We can use News, which is it's basically a data model for Cassandra node based collection. So highly scalable. Throws many as large of a Cassandra ring as possible, and you collect millions of things per second, kind of a speed, right? Big scale.
And not utilize
It's the Cassandra node is a separate server, so whatever you give it is what it uses. It's very hungry kind of a database. So that currently exists. Yeah, thank you. Over time, maybe. I think we're good. Anything else? Anybody else? Thanks for coming. I hope you have a good show. Come by our booth, 304.